Okay, so first I want to do this first. Okay, the exercise. Okay, so I hope that you guys are ready. I already started recording, so please turn on your cameras. Okay, so you have question number 1. A box is pulled with a string of 40 degrees at an angle from the smooth with a force of 5 Newton. So what is not written over here is the 5 Newtons lah, which kamu kena tulis sendiri. Okay, so if the mass is 2 kg, calculate the acceleration. This whole chapter, 1.1, 1.2, 1.3, kan, all centers around the same formula, which is F equals to ma. Okay, so everything, 1.1, 1.2, 1.3 kan, is F equals to ma. Okay, we will use this formula a lot. Okay, so what is the... First of all, when you do this question, okay, we must always resolve the forces. Okay, resolve. Kita mesti leraikan itu daya. We must do the resolution of forces. Okay, so today I'm not going to do alphabetical order because everybody is like, okay, Adam bersedia lah, kau yang first ini. Lepas Adam, Eliska. Lepas Eliska semua kan. So we're going to start with the person that is yawning. Mordecai, you first. Okay. I know it's a long day. Okay, but let's just try lah. Okay, tell me the two forces involved. How do I calculate the value? Is 5n, bila saya resolve, dia akan jadi apa dan apa?
Horizontal force.
Okay, tell me how to write the horizontal force.
5 cos 40.
5 cos 40, okay, and the vertical force will be?
5 sin 40.
Okay, 5 sin 40, yeah. Now, probably the thing that I didn't mention yesterday was this lah. Which of these horizontal or the vertical forces, okay, you can turn off your mic, thanks Mordecai. So, antara horizontal dengan vertical force, which is the force that is involved in the movement of these 2 kg? Okay, so yesterday we saw this situation like kalau kamu tarik bag kan, okay, the bag is not going to move up, it's going to move forward. Okay, so actually the force that we're talking about is only this force. Okay, because the acceleration is going to go this way. So we are saying that it's going to be 5 cos 40. The force is 5 cos 40, okay, equals to the mass is 2 kg times the acceleration. Okay. Kenapa dia punya resultant force hanya 5 cos 40 sahaja? Kenapa saya tiada tolak ke belakang? Why is there no force to the back? Can anybody tell me? Why is there no force to the back?
Because it's a smooth surface.
Because it is a smooth surface. Okay, smooth surface means kita tidak payah fikir sudah pasal di belakang. Okay, so tapi okay, let's say kamu betul-betul mau tulis dengan cantik, dengan secantik-cantiknya lah. Okay, so you can write 5 cos 40 minus 0 lah. Okay, you can write minus 0 because 0 is the frictional force. Okay, equals to 2 times A. Okay, so you will get A, the answer will be, can somebody tell me what the answer is? 5 cos 40 divided by 2.
1.92 ms.
1.92. Okay, ms negative 2. Okay, very good. So yesterday during the horrendous Wi-Fi and everything kan, saya lupa mau bagi tahu yang ini ada kaitan dengan F equals to MA. Then this morning when I was looking at this exercise, I was like, alamak, saya lupa bagi tahu. So yeah, so I'm using this exercise and opportunity to tell you. Okay, same situation. Okay, a box is pulled with a string at 45-degree angle from the ground with a force of 15 Newton, but this time there is a friction. Okay, the friction is 8 newtons to the back. Okay, same situation macam tadi, tetapi sekarang ada geseran. Okay, Damir, can you tell me the horizontal force, macam mana saya mau tulis?
15 cos 45.
Very good. Okay, 15 cos 45. Valerisa, can you tell me the resultant force? ekoran daripada pergerakan ini?
15 cos 45 minus with
Very good.
8n.
Okay, fine. 8n lah. Okay, very good. So remember, we always have to think about resultant force. Okay, ini adalah sama dengan 3a. And lepas kamu kira-kira, kamu akan dapat A equals to, Jericho?
Wait, sebelum kira lagi.
Oh, okay. Saya pun belum kira. Saya don't have the calculator. Oh, I do. I think do. In cos 45 minus 8. Okay. It should be about negative 0.869, possibly. Okay, meters per second square. So, yang kita belajar in the first subtopic kan, don't forget okay, cuma in the first subtopic, we are only interested in kalau dia betul-betul kiri kanan atau atas bawah bahkan. So in this second subtopic, we are considering the real life situation where kalau kita tarikkan, memang orang akan tarik dengan sedikit. There's always an angle. Okay, so we don't forget the cos and the sine rule. Okay, that we use for this. Okay. So now you have what we call an inclined plane. Okay, situasi inclined plane dalam bahasa Melayu is called a satah condong. Permukaan condong seperti ini kayu. Okay, so this kayu is a permukaan condong. Okay, so the forces that are acting on an object, okay, in a satah condong are like this. Number one, you have a force that is going downwards and dia memang directly down. Okay, they memang directly down because this is the earth lah. Okay, earth is here. Okay, earth bukan di sini ya. Ramai orang akan fikir ini yang earth. Sorry tidak earth is always downwards. Okay, so jangan salah ini salah. Okay, so the first one is downwards and we call this the weight. Okay, and usually weight, by now you should know already lah how, if I give you a mass of m, how do I calculate the weight? Aliska, macam mana mau kira weight kalau saya bagi kamu m?
Times with 9.81.
Okay, very good. Okay, m times 9.81, so you get the weight. Okay, second force is upward. Okay, and this is a normal force, okay, yang kita selalu jumpa, which we call a reaction force. Ini biasa. Tapi yang saya mau kamu perhatikan sekarang adalah arah normal force itu. Okay, in the old situation, when we had an object and then over here bahkan weight ke bawah and R adalah ke atas like this. Kan? But on an inclined plane, okay, the normal force must be 90 degrees to the surface. Ini yang sangat penting, yang selalu orang lupa. Okay, normal force dia mesti 90 darjah kepada permukaan di mana dia bersandar. Where it is leaning on, it is always 90 degrees there. So you must never draw the reaction surface kan exactly opposite the weight. Ini salah. Okay, the reaction force and the weight is two different directions now. Okay, on an inclined plane. Very special case, inclined plane. But inclined plane always you will see one. Okay, you are at the age where I think most of you are at an age where this year some of you are going to be sitting for driving license. Well, assuming that PKP tiada lah kan. And one of the tests in driving license is bukit, you know. Okay, if you heard of people yang pernah ambil driving license kan, paling digeruni adalah bukit. Sebab kau kena naik bukit kan, lepas tu kau kena stop. Okay, lepas itu kau kena tarik brake, and then kau kena bagi tahu, okay, saya mau jalan sudah. Okay, and then you have to balance the gear supaya kamu punya kereta tidak undur ke belakang. You have to go forward. Okay, so itu di mana selalu orang gagal. Okay, so anyway, coming back to this, this is real life situation now. Whenever you're at the bukit kan, all these forces are there. The third force is of course the force going behind, which is a frictional force lah. Ini biasa. Okay, frictional force, because dalam situasi begini, bahkan contohnya inilah, kalau ini kereta kan, naturally kalau kamu lepaskan brake, the car is going to go downwards. Okay, the book is definitely going to go downwards. Oh dear, sorry, hold on. Okay. Oh no, oh okay. So, why doesn't the book slide down? What do you think? Can anybody tell me? Why doesn't the book slide down? Sorry, we assume that the book doesn't slide down lah. Apakah keadaan yang akan menyebabkan the book doesn't slide down? Think of what we studied in the first subtopic. Anybody want to suggest an answer? Why doesn't the book slide down? Very rough surface. Okay, very rough surface means the friction is high, but almost there. I think Oswald has kind of a good idea. Shafiq, are you sent? Oh, tiada karan ke Shafiq? Cause like kamu, like, are you trying to get my attention by flashing the flashlight? Or are you listening to the song Flashlight now? Seriously, don't okay. Listen to me. Listen to the sound of my voice first. Okay, so why the book doesn't slide down? Because this W is a very important force. Okay, it is resolved to two components. Okay, what I want you to do is I want you to turn your head. Okay, turn your head until this permukaan menjadi lurus, ngam-ngam ke bawah. Okay, you turn your head this way. Okay, you see kalau dia lurus ke bawah, what you will see is this is the book. R ke atas sini bahkan. Kan? And then F adalah ke belakang sini. And you will notice that the W, actually the W is slanted. Do you see that? The W is slanted. Kalau katakanlah saya kasih ini condong bahkan, saya kasih flat macam ini bahkan. Tapi itu R, W dan F kan, I don't do anything to the R, W and F. I just bring it together with me. You will see that the W actually is the sengit force. Kalau dibandingkan dengan the surface. Okay? And we already did this yesterday. Any sengit force, apa-apa force yang sengit kan, boleh kena resolve to the horizontal and the vertical. Okay, which is these two. Alahai. Okay, so the vertical is over here actually. Okay, the vertical is over here. Okay, now, so this is another important thing. So, depending on the angle of the bukit so let's say the bukit's angle, okay, is theta degrees. Okay, it is the same value as the angle that is touching the vertical component. Okay, ini sangat penting. Ini selalu orang lupa ini. Sudut di bukit ini adalah sama dengan sudut yang menyentuh paksi vertikal, paksi Y. Okay, paksi vertikal. Okay, paksi menegak. Which means that this one, the vertical component, okay, the vertical component now, we have to use cos. Sebab the vertical component yang menyentuh the angle bahkan. So it will be W cos theta. And the horizontal component will be this, the sine. Okay, because of where the angle is. The angle is touching the vertical. Makanya the vertical itu yang cos. The horizontal yang sine. I mentioned this yesterday. I said be very careful. Okay, be very careful where the theta is. Di mana itu theta, di situlah yang kena cos. Okay, and then the opposite side is sine. Unless you want to do what we did yesterday with Chris Fiaka itu yesterday, yang sangat genius kan, dia kasih tukar dan ubah. Oh, ada karan sudah Syafiq. So no need the flashlight sudah kan. Okay, bravo. Okay, so the WY is W cos theta. Okay, so this is the thing that we have to cover today lah. Okay. So the book doesn't slide down because the WX and the F is the same value. Okay, the X component and the F is the same value. That's why the book doesn't slide down. Very normal lah kan, kalau kiri sama dengan kanan, objek itu tidak akan bergerak. Okay, this is what we studied since first subtopic. Okay, The forces acting on the book are balanced. Okay, but Oswald's answer just now is also quite good lah. Okay, there's a very high frictional force. Okay, but as always, if the resultant force is 0, the book will not slide down. Okay, now let's do a couple of questions. Let's do this together lah. Okay, although saya akan panggil kamu untuk yada, tapi bagi tahu saja. Okay, so a block of wood, and this is 5 kg. Okay, is placed stationary on an inclined plane, which makes this one 30 degrees. Dia bilang. Okay, 30 degrees with the horizontal. Now, again, saya sudah cakap, the angle on the hill is always the same as the angle on the y component. This one is obviously 30 already. Okay, mesti. Boleh dibuktikan, you can use mathematics and solution of triangles to buktikan, but I'm not an NMATS teacher lah. You ask Puan Lim ke your NMATS teacher? Ask Puan Lim to prove it for you lah. Okay, but right now just accept it as it is. Okay, let's label the forces. Tell me where is W, where is WX, and where is WY. Let's ask. Sorry, I want to ask everybody, but I also want to ask. Let's choose somebody special lah. Shim. Since your name starts with S, your special Shim. Okay, Shim. Tell me where is W, where is WX, and where is WY. Oh, okay.
Not sure. But I try lah.
Try. Okay, I tell you what, I point lah. I point, then you know which one I'm talking about. Okay, this one is what?
Yeah. WX.
Okay, WX, the horizontal component. This one?
Yeah. Y. WY.
Okay, WY, and this one will be W.
W.
Okay, thanks. So most importantly, remember that the W is the Segnet force. The one that you have to resolve is the W. Okay, right. Question number 4, the reaction force and the frictional force. Okay, there are only 2 more errors left lah. Okay, and I feel that I don't want to call somebody just to answer to this one, so I'm just going to do it lah. So the N is here, the normal force. Okay, and the F is always to the belakang. Okay, now let's determine the value. Magnitude is value. Okay, determine the magnitude of W. Okay, how would you count the W? Daniel?
5 times 9.81.
5 times 9.81. Since we're doing this together, so don't worry, I count for you. It is 49.05 newtons. Okay, very good. So the Segnet force is 49.05 newtons. Okay, so now I want okay, I want the twins, Wilson and Wilson. Wilson, you do WX, Wilson, you do WY. Oh, no, you know what? Actually, we should switch it. I always call Wilson first. Okay, Wilson, you do WX, Wilson, you do WY. Okay, tell me what to write and tell me the final answer.
49.05 sin 30.
Sin how much?
30 degrees.
Okay, sin 30 degrees. Okay, this will be, how much is it? Can you calculate? Myself calculate lah.
24.525.
525
Yeah.
Okay, 525 newtons. Thanks, Wilson. Wilson?
0.05 cos 30, is it?
Okay.
42.48.
Okay, 42.48 newtons. Okay, now let me ask you this question. Let's say this box, this block of wood, dia tidak bergerak. Okay, let's say dia tidak bergerak. Can you tell me how much is the frictional force? Let's say this object is not moving. Okay, how much is the frictional force? Anybody?
$24.525.
24.525. the same as Wx. Okay, so very important point. If Wx equals to F, okay, two situations. Remember, if the resultant force is 0, there are actually two situations. Number one, the block is not moving. Okay, what is the second possible situation? Anybody? We did this in the first subtopic. Either the block is not moving or alah, begitu saya mengharap sudah ada orang unmute, terus dia padam mic.
Acceleration equals to 0.
Very good. Okay, acceleration equals to 0. Sorry, who was that that answered? Who? Oh, Brandon. Oh, okay. Okay, Brandon, since you're this one, let me go forward a little bit. Acceleration equals to 0 means what?
Velocity is constant.
Very good. Okay, constant velocity. So it is moving, but with constant velocity. Okay, or it cannot be also moving. Remember this, this very, 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 very important. Okay, since the first subtopic saya banyak kali cakap sudah. Sampai Syafiq Iqbal punya flashlight pun saya ingat. Okay, next question. Now I have to go through all the animation. Sorry, Okay, so it looks like it's very good. Alah, tengok saya yang sendiri yang jawab. Kau tengok bah, belum lagi ditanya, saya sudah tanya. Okay, what if Wx equals to F? We sudah cakap lah. Okay, the block will be stationary. Okay, or moving with constant velocity. Okay, macam mana kalau Wx adalah lebih kecil daripada F? What will happen? What do you think will happen? This is a very strange question, but think about it. If Wx yang kecil, F yang besar, what do you think will happen? Okay, anybody except for Brandon lah. Takkanlah Brandon mau kena belanja berapa ribu kali makan. What do you think will happen if Wx is less than F? So Daniel says stationary. Louis said the block of wood will still slide down. Okay. That's interesting. So one person say it's stationary, one person say it's slide down. Wait. Louis, Wx is smaller. So the weight is smaller, I mean the weight component is smaller than the frictional force. So Louis say it's slide down, but then he say wait. Mordecai left the meeting. The block of wood will not slide down. Okay, but siapa yang cakap tadi stationary? Okay, isn't it the same stationary and not slide down? Okay, so actually, I'm very glad lah. I'm very glad that none of you said that the block of wood will slide up lah. Because I think it's very scary lah. Kan? If there's nothing pushing the wood, but just because there's a frictional force, kan, terus the wood will slide up by itself. Okay, so I think that's a very important thing that you guys are noticing lah. Okay, so that's very good. Okay, sorry, animation. Okay, so it will be stationary. Or like Louis's answer lah, the block of wood will not slide down. Jangan cakap the block of wood will slide up, Just because the F is bigger doesn't mean that the block of wood will slide up, okay? Mesti pakai logic juga lah, okay? Maybe you can say the block of wood will slide up because there is a ghost pushing it up. Atau satu, I know, tidak tahu lah, a vampire pushing it up. That one different story lah. Okay, so the Wx equals to F is usually constant velocity or can also be stationary. Okay, and then of course, if the Wx is bigger than F, definitely it's going to accelerate. In what direction? It will be accelerating downwards lah. Actually downwards this way lah, not really downwards ke bawah. Back to this paper, and I want you to try, okay lah, 2 questions only kan? Okay, let's do the 2 questions now. I'm going to give you about 15 minutes. Okay, can you do 15 minutes? And then after that, we will do this, we will check this thing together. Okay, let me see. Oh, okay, only 2 questions kan? Okay. I suggest, my suggestion is lukis balik. Okay, lukis balik, put all the information in the lukisan. It is easier to see lah dalam lukisan kamu. Okay, I'll see you in 15 minutes. Okay, come, let's continue. So I'm going to ask, so what I'm going to ask you to do is, saya pun lupa sudah apa saya mau cakap. Okay, what I'm going to ask you to do, I'm going to ask 4 people, one person to answer A, B, and then the next one A, B. Let's have Angeline. Okay, let's have Angeline and Shafiq Iqbal for the first question. Okay, and then let's have, let me see, Zulaika. Okay, I haven't heard Zulaika for a while. I hope her connection is okay. Let's have Zulaika and Rania. Okay, for the second one. Okay, so let me draw the situation first. And then after that, you tell me what to write. So this is 5 kg. Okay, over here, this is 40. Okay, so obviously this will be 40. Okay, yada yada yada. So, sorry, the first one. Terus Shafiq Iqbal left the meeting. Apa ini? Kurang ajar. Sorry, who is Shafiq's friend tadi tu? Si Angeline. Okay, Angeline. How do you answer 1A? Let's see if Angeline is in here. Angeline, are you here?
5 times 9.81.
5 times 9.81. Okay. Why do we do this?
To find the reaction force.
Are you sure? 5 times 9.81 is which one? Take a look at this. 5 times 9.81. You see, the reaction force is actually the same as this one. Done? So, welcome back, Shafiq. So 5 times 9.81 is actually just the W only. So where's one circle? I want to find this one, 5. Because the reaction force and the W cos theta is the same. Okay, do you get that? Okay, so anyway, tell me how much is 5 times 9.81 first? At least I know what is the weight.
49.05.
Okay, 49.05. But it's not complete, okay, because you only just found the weight. Okay, remember, the reaction force is the same as the vertical component, and the friction is the same as the horizontal component. Okay, Shafiq Iqbal, do you think you can complete this? After I find the weight, then how do I find the reaction force?
Mm, 49.05 sin 40.
Sin 40, the reaction force. Are you sure? Wait, what are you doing now? Are you doing A or B? You're giving me B or A? Did you hear my question? Oh, yang kamu baca tadi kan is B or A?
B.
Oh, B. Oh, okay. Okay, fine. So this is the frictional force now. Okay, this is the frictional force. 49.05 sin 40. What's the final answer?
31.53.
Okay, 31.53 newtons. Everybody okay with this for question B? Yeah? Okay, let's complete question A. We haven't completed question A. So far, Angeline has only given me the weight, but not the reaction force. Okay, we established earlier that the reaction force is the same as W cos theta, and the friction and W sin theta are connected. Okay, so the reaction force will be 49.05 cos 40. Okay, because it's not moving up and down now. All right, so 49.05 times cos 40 will give us about 37.57 newtons. Okay, all right. So don't worry about this, Angeline. Just we learn from this mistake together. Okay, all right. The second pair of people is Zulaika and Isabella. No. Zulaika and Rania. Right? Yeah. Okay. So let me see. Same situation except that the angle is now 30 degrees. Okay, you still have a 5 kg box. Weight is always this way. Okay, and then of course the same thing lah. Around the reaction force, and then the two components over here. Okay, Zulaika, over to you.
Five times 9.81.
Okay, yeah, so we get the same answer as Angeline just now. And then after that?
49.05 cos 30.
Okay, very good. What's the final answer?
42.48.
Sorry, 46.
42.48.
Oh, 42. Okay, unit is?
Newton.
All right, excellent. Okay. Everybody okay with this answer? Can? All right, good. All right, last but not least, Rania, one of the first to enter just now. Terus lain kali orang tidak mau first sudah, nanti kena panggil. Sorry, Rania, are you ready?
Yeah, I'm here.
Okay.
49.05 times with sine 30.
All right.
And then the answer 24.525.
Okay.
After that, 24.525 equals to 5a.
Very good. Okay, and then?
And then divide it by 5. So the answer is 4.905 ms negative 2.
Very, very good. Okay, because the question is different. Question is acceleration. So kita kembali kepada this soalan yang tadi ini. Kan F equals to ma. Except that, kenapa Rania, sorry Rania, I have to ask this question once again. Although I think you know the answer. Kenapa the force ini kan tiada tolak apa-apa ini? Why the resultant force hanya satu saja kamu ambil kira?
Because it's a smooth inclined plane, so no friction.
Because, very good, okay, because there's no friction. So tiada apa-apa untuk D minus.